Okay, welcome, people of Earth, to day 19 of Advent of Code. I started a little early tonight because last night's code was vaguely interesting. Not really from an algorithmic point of view, but just from like a programming language and code structure perspective. Um, Let me pull up my little thing of reflections. Okay, so what did we do? Where is my code from yesterday? No. Yes, here we go. So the first thing that I did yesterday was tried to just actually paste the input into Swift and have Swift parse it. And Swift accepted this, which I found puzzling because it was only then that I realized that they were homogeneous arrays, which are not a thing in Swift. No, they were heterogeneous arrays, which are not a thing in Swift. An array has to have all elements of the same type. And so I didn't understand what Swift was doing with that, because let's actually give a little example. Come on, Swift. There we go. If you say, if you do something like that, it rejects you. And similarly, if you have an array of arrays, but the subarrays have different types or different levels of nesting and so forth, that doesn't work either. And it turns out the reason that it accepted what I was doing is that Swift will not implicitly create an array of the any type, right? Because it could do that here. You could have an array of any and put whatever you want into it, and it actually, that's what the error message says. Swift will implicitly create an array of any's. So if instead of that we added another level of arrayness to it, then it just works. And that's what was effectively happening to our input yesterday. It was considering an array of any's, which worked because every one of these structures had an outer array, and then I made an array of all those arrays, so it was an array of any's. So that's why that worked, which I didn't understand at the time. And when I was trying to do that, column editing would have been useful, and in fact, you can do that very easily in BBEdit. You just, hold down Option as you drag, and then you can, prepend to anything. So, let's actually just, yeah, there we go. Okay. And also, so I wasted 5 minutes doing this thing that was a complete waste of time because I hadn't really thought anything through very clearly. You know what? That's fine. I realize you're not going to do well in programming contests if you do that. But I think being willing to just do something, I don't feel bad about that. I feel bad about a lot of other mistakes I make, but that's fine. And I was having a lot of trouble when I started yesterday, so what I did, I found a part of the problem I did understand, and I started programming that one little part. And that's definitely a good approach when you have some bounded problem like an Advent of Code puzzle. I'm not quite sure what to say about this kind of take something that you can do and do it in real life, because I have seen programmers, and in fact entire teams, go for days, weeks, and on one occasion I remember months building things they knew how to build, despite the fact that they didn't know how to build, how to actually get from where they were to the goal they wanted, and it was fairly obvious that it wasn't possible. Nothing they were building was at all relevant or useful because there was no way from here to there. And so in real life, there aren't necessarily clean solutions to things, and you have to face up, we're not going to be able to solve this, so we have to actually build other systems to get around it because certain problems simply are intractable. And that's the one conceit of these programming contest things, is there is always a straightforward solution, right? Because they wouldn't give you these problems. And real life just isn't like that. So that seems worth remembering. So yesterday I got nothing. I mean, I really didn't write a single character of code for 10 minutes, which I think is probably a record for this year. Again, that's sometimes that's how it goes. And it turns out everyone kind of stumbled on this one, and it's possible the little more thinking up front would have actually got me to the finish line faster, maybe. At the very least, throwing lines of code together in those first 10 minutes probably wouldn't have accelerated my time at all. So, whatever. So the big thing, and I have 8 minutes to do this, and the reason I started a little bit early was that there are a lot of ways to do what people call discriminated unions, which is kind of what we were doing yesterday, where you have an object and it can take one of two forms, or one of, n many well-defined forms, all of which are distinct from each other. And yesterday it can either be a number or it can be a pair. Those were our two options for yesterday. And in many cases, in real life, there are a huge number of factors that weigh into which of the many possible representations for that you want. But there's something nice about these very small bounded problems you get in this event, because you could choose any of these things. There isn't a huge amount between all the different possible representations, so you can toy around with all of them and see how they all feel. And what I banged out most quickly, just because it came to mind first, was that I just built a object that had two optional fields in them, one representing each of the possible representations. And that's fine. That works. It gets you to the finish line, and it got us to the finish line. And in fact, it's just as fast as all the other options. I suppose that, like, the theoretical and academic downside to this is that now you have invalid representations. What happens if both of these are non-nil? Or what if they're both nil? That's super weird, and it's weird that your program can end up in this state. And I mean, you could assert invariance at every function and so forth, but one of the principles of, like, really beautiful code doesn't need to insert invariance because the invariants are implicit in the types and structure and everything, and so you can't possibly do it wrong, right? But very often, and that's actually, like, one of the big things the functional folks go on about. They are very into, like, oh, everything is correct. If it type checks, it's got to do the right stuff, because that's how it all works. My view is that it very often makes your code even more complex and obscure to try and reach the state where invalid states are impossible. So I don't have a huge problem with this, but you should know that there is this downside, that there are invalid states, right? So the alternative that I mentioned yesterday was that you could use enumerations. So instead of having a class with this pair of optionals, you could have, an enumeration that looks like this. You have these two different types. One is regular, which is a bad name, but it was the one used in the problem, that just contains an int, and the other is this pair. And you have to use this indirect keyword if you're containing the enumeration itself, because then it's by reference and not value, and yada yada yada. But anyway, this eliminates the invalid state issue, because a num then has to be exactly one of these two, and you can use a switch statement to have code for each one of the two possible representations. The one thing that I found a little bit weird about this, and that I freely admit that I got wrong, my 5-minute pass just to convert the object-based code to the enum-based code, which is very straightforward because enums can actually have member functions, mutating member functions just as well. So it's not a big change. It's a few lines. However, enums the actual associated values that you shove into these enums, which is another Swift feature, because enums aren't just a bunch of things. You can associate a value with, or you can associate an arbitrary structure with each enumeration type. Um, you can't actually get at these things in any kind of privileged way. You can't do mutating operations on them. But what you can do within a mutating function in an enum is you can assign to self. So you can just build a brand new enum value and then assign it to self, and then you change what kind of enum you are and or what values are associated with that enum. And I had forgotten to do that because I had been, let's go to somewhere we have a mutating like this. I had done this this thing, every function effectively starts with switch self. And then, you capture whatever the associated values are. And I had forgotten that you then have to assign to self here. You can't just change this associated value because you've captured it. You've made a copy of it. It's not going to change your own associated values. So then what you have to do is recreate the enumeration value and assign it to yourself. Anyway, that was vaguely interesting, and that's part of what I like about, it's an opportunity to explore parts of the language you don't use very much, so you remind yourself of these little things. So I found that interesting. What else did I say? I benchmarked these things, and enums were actually marginally faster in debug mode, but a bit slower when everything is optimized compared to the object case. Anyway, because we are running out of time, because I can talk forever about code structures, the other obvious way to do it is the like super OO thing, with you write a base class and then you write two subclasses with different representations, but they both implement methods of the base class. The big thing in Swift, that struck me as a C++ programmer from back in the day, is that there's no such thing, as far as I know, as pure virtual functions in Swift, or abstract functions. I think that's the Java terminology. So you do have to provide implementation, so the compiler doesn't really help remind you to implement these things. And that strikes me as, I don't have time to rant about this, do I? How are we doing? 1 minute. It strikes me as very similar to, on the original Mac, they didn't put arrow keys because they were afraid that if they put arrow keys on the Mac, then people wouldn't use the mouse. So it wasn't that they were against arrow keys, it's just that they knew they would stop people from doing things the right way, the real way of the future. And I suspect that, that not having purely abstract base classes and pure virtual functions is Swift's way of saying, you really need to learn about protocols. Protocols are great. Protocols are like the whole way that we should be doing this, because all this implementation inheritance crap is nonsense, and you should always use protocols. So, anyway, I wonder if they will be adding pure virtual functions at some point. Anyway, we need to get started on day 19, don't we? So let's move right on to that. Okay. Okay. Interesting. I can never remember what the math is for doing rotations. I mean, it's not complicated, but I always get that wrong. So let's look forward to getting that wrong. One, wait. Wow. 79 beacons. Full map of beacons. How many beacons are there? Wow. This sounds hard. How many scanners do we have? 25 scanners, and they can all be at arbitrary positions. How do you know what beacon is which, man? I don't know. So let's know what are we doing. Okay. Okay, we had something to read records, didn't we? So what is our input? Records. Let's see if our records thing works. Just to get us running. Oh, we don't need that. Hold on. Let's go to a shell that has. Okay, so we have all those things, and then for each one, can you do this all on the same line in int? I never do, but I believe this is a feature. Oh no, let's. Zero. Let's see if this runs. Nope. I was so close to doing all three of those correctly. I claim. Okay. Okay. So we know how to read our input. Let's do. Okay. Yeah. 2026. Is that right? Let's just check. Scanner 0 to 25. Yes. So. Okay, so we got our input. I still don't have a strategy. So let's go back and read the problem and come up with a plan. By finding pairs, they can both see at least 12 of the same. But how do you know if they're the same beacons? 1, 2, 3. Because all absolute. How do we know that they can both see the same 12? Actually, hold on. How many points are each seeing? Oh, okay. So do we know that adjacent ones can see at least 12? Okay. By finding pairs. Two dimensions. Negative 16, 24. So somehow, how do they know that that's the same? I don't understand. The 12 beacons they both detect. Oh, because the last 12, so 686. So the last 12 here are the first 12 here? Is that the rule? In the same order. Overlaps with scanner. So the first part of this problem might be trivial. Might require no computation at all, right? So if this is the case, so 26, blah, 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 I'm going to get a little confused by all this, but So what we do is we subtract 24 from everything in the middle here, and then 12 from the top two. So we sum up all those counts and subtract 24 times count minus 1. I appreciate this first problem because it forces me to answer my main question I had. So, uh, I'm just doing this because we already have the code here and we're not going to use reduce map or some crap like that. Okay. Code minus 24 times scanners count minus 1. 24? No, 12 times. Wait, what? I'm going to look at a column of numbers, and that will help me think it through. So there are actually 26 fresh ones, and you subtract 12 from every... Yeah, so 12 times all but 1. Hey. T? Tote. Maybe... What is that parenthesis? 67 tote minus 3. Maybe there are 367 scanners. How many? No, 367 beacons. Sorry, I've been saying that wrong the whole time. 367. Okay. Well, let's see. In total, there are 79 beacons. What does that mean? The full list of beacons. Overlaps with scanner 1. Scanner... Wait. How do you know? How do you know which ones overlap with each other? I don't get it. How do you... I just don't get this. They're in the same order. Still in the same order. 686, 605, 515. 686, 605, 5. Why are they in the same... I don't... Am I supposed to be figuring this out, or is this given to me, what the overlaps are? I don't want to do like on one of those days when I solve a much harder problem than I'm being asked to. I really don't. By finding that both can see 12... And then negative 336, 95. Actually, let's... come on, just drag. Okay, so scanner 1, not you. So what are you saying? The same 12, 605, 515, negative 336, and then, but not that one. Oh, okay, so I was not understanding. Negative... Negative 476. What? Negative 476. Oh yeah, sorry. Negative 460. But how did hmm. I don't I don't understand how so we okay. So maybe we are solving the broader problem here. So there can be so we can just try every pair of scanners together. And then how do we choose 12? I mean, so we choose about half of the things. An algorithm is not coming to mind for doing this. So we don't know which of these things overlap. We're just going to guess which scanners have overlap, but then we're not. How do we figure that out? Now we can try. So how many different? Well, let's. Okay, what are some tools we know we're going to need? How do we rotate a scanner? Um, do, 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 do. Um, do, 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 rotated. Um, um, thing. Okay, did I get any of that syntax right? Okay, I still haven't really thought about how I'm even going to implement this function. So, actually, how does this work? Case.let. Or you can put the let in another place, I think, actually, so it doesn't really matter. But case. Um, um, Okay, so if uh, you rotate around the x coordinate, um, then the other things change. I'm gonna have to draw myself a little picture here. So we're looking down the x-axis. Let's look down the z-axis first, shall we? Um, Looking down the z-axis, then we just see x and y, right? And you have um, uh, x comma y there. And one rotation, what you get is uh, the x is going to be, so it's going to be y comma negative x is what you get. So um, um, out out x. Oh no. Equals out y negative out x out z, right, and then out equals p. That seem right? And if that's right, then the other cases are similar, right? We just have to x. Okay, so what happens? So they swap and one goes negative. Does it matter which? It doesn't really matter which, because that's just a matter of direction, and we're fairly agnostic to that, I think. So okay, so let's. None of this is useful, I think. So let's get rid of that noise and let's. Three. Around the z-axis one turn. Oh, I wasn't even close. You know what? Let's just fix that. that? Extraneous. Oh, I wonder if everyone is going to be slow at this. That's our only real chance, isn't it? Extraneous and beacons append. Yeah. We could have made constructors with, so you can call it either way, just to make all our existing code work, I suppose. It's the sort of thing I sometimes do. Missing return. Yeah, that makes sense. Because there's no return. And what are these warnings? Nope. Okay, those warnings would have been driving us crazy all night. Okay, so... Oh, what are we? 1, 2, 3. So, this is 1, 2, and 3 high, and then it goes to x2, -1. That looks like a reasonable. Okay, let's assume we're rotating correctly. Great. Now, why not write a translation function? Because it's too easy, maybe? I mean, it's going to be completely dull. Instead, let's think about how we're going to use these things. So we go back to our problem, which I still haven't really understood. By finding, how do we find the ones? Are we really supposed to, 24, let's make 3 times facing positive or negative. 24 different orientations. I only got 12. How is that? No, because it's because 4 times. Oh, because there are symmetries between the different rotations. So if you take, there are 4 rotations, so 4 times 4 times 4 is 64. 4 times 4 times 4 is 64. So I think there are 64 that we can easily generate, but only 24 of them are distinct. That, yes. Okay, I buy that. And I'm sure if I did 3-dimensional geometry on a regular basis, I would have full confidence. Why are they in the same order, though? I just don't understand. Because all absolute overlapping cubes. They're just telling us that, but we would need to figure that out in real life. The 12 they both detect in the same order. Why are they in the same order? Doesn't make any sense to me. I'm going to look again. They really are in the same order. Are 686, and then 605, 550, and negative 336, then negative 476, negative 460. if they really are in the same order, well, okay, and how many ways are there to choose 12 from 24? There's a lot, aren't there? Um, yeah, there are a lot. So we can't just go through all of them. So a hint here might be, but you really do, because they might not line up at all. How do you... So we could go through... Do we want a set with... But the order seems to matter. I don't... Why are they in the same order? The 12 beacons... Should we ignore the order? That's a little puzzled. What are you doing, dog? Okay. You gotta smell. What is... I think the dog's okay. Well, we can just try... Well, okay, we can try all the 24/64 rotations. Then how do we match up the translation? Assume... So pick one and assume it lines up, and then you get a matching translation, and then see if you get 11 others. Right? Okay, so let's try... Okay, what am I doing? 0, 1, 2, 3. Okay, that sounds right. We should really eliminate the symmetries, but a factor of what, 4? It's not going to make any real difference. So, okay. We don't need any of this. Oh, yes, we do. What am I doing? Multiplications. Don't need that. We build our scanners, and this is what we don't need. This is all nonsense. We don't have a clue what that's all about. But then okay, so we built our thing. Okay, beacon in S0. These numbers are still quite manageable, I think. Okay. Equal. Okay. And then rotated and translated S. Plus, it's not plus, is it? But sorry, my brain is seizing up. Plus dot 0x. Okay, now let's think this through. So we want BB plus trans equals BA is what we really want to get. And trans, and what does that mean? The trans is BA minus BB. We might have gotten it right. Who knows? Maybe we got it right. Why not be optimistic? Too many people are, just program assuming that they have to think everything through, and that's no fun. You might as well just do stuff. Okay, point 3. Now, okay. Let's make this hashable. margin set equals of S0 let S set. These variable names are definitely going to confuse me later on, but right now I know what they mean, so why would we not? Rotated and translated set. And then how do you intersect two sets? Come on, where's the set? Where's set? Set has to be in here. Oh, you're kidding me. Come on. Set. Here we go. Come on. Go. Intersection method. Just take me to the intersection signature. Here we go. Okay. If intersection okay, so, I mean, if we do this, the rest is purely mechanical, right? But I don't know if our code works, and I'm very worried about debugging this code. So let's, wait, S? No, not S0, scanner 0. Type safety saves us from some mistakes that would be quite annoying to debug in Python. But, so that's nice to know. Okay, set 69. If, yeah, that makes sense. Okay. I mean, what fun would it have been if our first attempt actually worked? Just the one, huh? Just the one. That's... It is good it overlaps on one, though. Oh. Let's just call that I. What? Same mistake. Oh, whoa. 1, 2, 3. Actually, hold on. Six, a whole bunch of sixes. I mean, and that could be the. Um, we can just. There we go. Okay, so 8, 11, rotation. Wait. 1, 2, 3, 4, 5, 6. Of course, when you have 6, you'd get 6, wouldn't you? Oh, or no, we're. Oh, it has to be a combination of rotations. That's why we're not getting it, isn't it? All rotations. No. 4. X turns. Oh. Yeah, this is all wrong, isn't it? Yeah, even creating that enum was obviously stupid. So, because this is the real number of things, right? So, boop-a-doop-a-doo. So, a rotation is really a that's a number of turns around each axis, right? And so, okay. Now, in zero, not dot. No, yeah, that looks a lot better. We're doing a lot of things less efficiently than we could, but not sufficiently badly that I think it's a problem. So, and it's always concerning when you go back and you see things in your code that are clearly wrong, like the range things from before that didn't match the range things down here. So that's not great. Any other code we need to change? Okay, so this is interesting. Let's see if I count. 12. it's still going. 12, 12, 6, 12. So it overlaps with 6, and the rotation is that. And we should have 12 of those. Oh. And it overlaps with 22, I think. Okay. Fair enough. Well, this is good, I think. Isn't it? So we found the correct thing for 2 of them, right? 12, so 6 and 22. Yeah, okay. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Z 1, 2, 3, Z 0, 2, 2. Okay, let's just take the first one. So, okay. So, array of three is the origin. I'm not even doing it. Gets me a dictionary from we can't oh oh, but we didn't actually need that, did we? Because it's a map from array of point threes to a pair of rotation point three, right? Okay. Now we just need to get this to work with that signature. Two. In RS, that's good. Let's say we'll also capture the translated version. Well, no, let's put it third, obviously. Or T, and the absolute measurements will be an array of 0.3, right? And we need to format everything correctly, or it clearly won't work, right? Origin. If this is 12, then S R T A of yes, right? And then we probably want to break or continue. We want to continue it, right? Okay, what is the problem here? Dictionary from an array to, oh, because we need a comma, right? We're not using our library at all today. Oh no, we use it to read the records. But I know, look at all this stuff. 79. Well, that, yeah, okay, I believe that. All makes perfect sense. Transform is not hashable. Where? On line 52. Why? Is it because rotation is not hashable? Did it actually explain that to us, or did we have to figure it out? Okay, come on. Can't find it out. Oh, I could have told you that. Is this crazy ass type? Empty. Yeah, okay. Okay. Now let's see if we get the same thing. Print origin and 2. Yeah, okay. Origin of 0 to is a set of 3 constructed from scanners. All the other scanners. So we should get 2. No. Extra argument. What? Match. What are we doing? Oh. It's quite slow. There are probably a lot of ways to make this go fat. That's very slow. What? Because we're printing. Yeah. Okay. I think um, uh, let's just print its count, shall we? Okay, and I'm a little curious. Let's actually optimize because it is slow. Okay, so if that works, um, if that works, so solved is da 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 da. Okay. How do you merge two dictionaries? Let's remember how to do this the right way, right? Merge. Use with current. We can just assert that they're equal or something, right? 2. Okay. Okay. So, solved equals that. Solved of we could have used a 0.3 for this as well, just because it happens to be the same structure, although it means something quite different. So right. So do, 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 do. Equals match. We should be efficient about doing this, shouldn't we? Okay, so let's. we're not quite there on this structure, but that's fine. Um, yeah, okay. Sorry, I'm not talking. I'm just trying to work out the code structure for looping because I'm looping over all these things, and every time we catch something new, we put it in the queue and we try and match other things against it. And I think we're going to exhaust unsolved before we exhaust our queue, but that will be interesting to see as well, won't it? Okay. And then let's. Let's see if it compiles. Let's see how close we are. 1, 2, 3, 4, 5, 6, 7, 8. Okay, and then what do we want all of the types. So we want the total number of beacons, right? So I'm still so C++y about this stuff. There was a one-line way to do that as opposed to writing a loop, but I think it's fine. It's quite slow. It's not a very efficient approach, is it? And that's more than 25, isn't it? Why? And. That's an and. Solved. Unsolved. It's not empty. Q. To that's wrong. unsolved, right? So we might as well kill it and start again. Mightn't we? So, in fact, and the unsolved are getting smaller, so this should be getting faster. Yeah, it is. Okay. Ooh, good prediction. 313. Let's just try it out. Hey, okay, 237. So we didn't, how far apart do the scanners get? Largest between any two scanners. So that's largest between any two. Oh, screw it. Let's just square it. I mean, we're already so unbelievably slow that this is not what's going to slow us down. Oh. Equals oh. Max of m. So well, I quite like this problem. It's very long, hour and a quarter already, and we're not. I mean, we're not necessarily done, are we? So quite a long problem tonight, but it looks like it was long for everyone, which makes me feel. Oh, and I'm sorry. I've been cutting off this. I've been cutting off the bottom of my. I don't know how long that's been happening. I apologize. So, let's see if that is the answer to part 2. Oh, crap. What? Scanners 2. 1197, yes. Plus 1175. 1249. Yeah. Oh, no, not you. Oh, well, this is a shame. How am I? How is this where I'm screwing up? All beacons. Um, we're subtracting, yeah. What is going wrong here? I don't. Well, I don't. Every time I run this, it's very slow. I don't. Uh, what? I don't. I don't get it. What am I doing wrong now? Okay, let's go somewhere else and just get a Swift shell. Oh, we don't need you. Okay, where is our Swift shell? Oh, this is a pain. But I know what. Um, 1197. Yeah. Plus. How could I possibly have made 3621? What? Plus. How could I have gotten the first part right if my coordinates are wrong? That's just doesn't make any sense, does it? Wait. 1713 negative 2. And then we said, oh, M. Yeah, okay, fair enough. But 14,000 in each one of these things is 4,010. No, I can. 14,225. Where are we getting this 14,225? Where does it change? We should have really spit this into a file, shouldn't we? So that we could do exactly this. Let's just cheat a little bit. Oh, we have a lot of scroll back. Come on. Come on. There we go. 12. 12741. 13570. So what happens right here, these claims are the farthest apart. So that is only about 200, only about 1100. Oh no, it's these two. Oh, so those are quite far apart. So 4,000, 3,000, 6,000. Yeah, that seems reasonable, but apparently we're not right. 14,225. Why? Why? Oh, the scanners. The scanners. Oh. Not the beacons, the scanners. Oh. 4. Um, NV. No. I'm dumb. And I could have reused the same variable, but, you know, I wanted it all to be... I'm dumb. Okay. Let's try it again. Oh, how long did this? So that was like 10 or 15 minutes. So we're actually going to lose places on part 2, which I almost never do. But it's happening. It's happening. So. So there are 26 of them, and there are this many. Okay. Let's try that then. Yes. 329. Well, I'm curious. So how long did it? So it took everyone an hour, and it took us closer to an hour and a half. So yes, we were still a ways out, but so what did we spent 12 minutes doing the second part, and we did lose a bunch of places doing it. So anyway, I it took me a while to understand what that problem was all about, but I enjoyed it. So anyway, I'll see you back here for day 20, and to reflect on this. So do tune. Oh, and I should mention, if people are actually watching this, could you comment on why? Because I never really watch this stuff. I'm not really sure why I'm making it, but I'm genuinely curious why people are watching me doing these things, whether they're looking for tips doing them themselves, if they actually find it entertaining, if there are things I should be doing differently. Do let me know, because I really have no idea what I'm doing or why, which is the definition of my life. But regardless, I will be doing it again tomorrow. So see you then.